Okay, so a few outlines of the topics in this unit. Most important source of delay in almost all digital circuits is capacitances, and that will be a very important focus of our unit also. So we have three components in almost all circuits: R, L, and C. And R is unavoidable. Every wire has a resistance R equal to rho L by A. And similarly, capacitance also we have learned that you probably have learned. We will go through it again. But every MOS transistor has something called as a parasitic capacitance that is associated with the structure. Unavoidable. There is no way to make it zero, so it will always be there. And similarly, every wire also, the wire is not floating in the air. There is going to be some insulation between the wire and the substrate. So that also forms a parallel plate capacitor. And these are all the sources of delay at the RC domain. And inductance also is there, but we will generally ignore the inductance because of a few reasons. One is inductance is very important, but it becomes significant only when we have a very high speed circuits. So the effect of inductance can generally be neglected when we are even at the megahertz, close to gigahertz range. Also, inductances can be neglected. So most delays at the digital domain will be at the RC level itself. And secondly, for primary inputs where we have the connection coming through the pin, those cases, because of the structure of the pin, which is much larger than the internal connections, wires, etc., is going to have a more significant inductance. So in those cases, we have to model the inductance. So in general, whenever we are modeling delay at the digital level, for most normal circuits except for ultra high speed circuits, we will call it only as the RC delay. And generally the product, suppose I have some circuit and I am able to calculate the equivalent resistance. Okay, resistances, there will be many resistances, but we use series parallel combinations and combine the whole circuit into one resistance. And similarly, capacitance also, we have many capacitances in the structure of the circuit. Use series parallel combinations, convert it into one capacitance, and the product of those two is what is called as the RC delay. That is, if I just multiply R and C, the number that I get, that is a measure of the delay of the circuit, and that is the simplest way to measure the delay, which is also called as the RC delay. That is the first thing that is highlighted under delay models, the second point. Another way to calculate the delay, which is the second delay model, is called as the Elmore delay model. This is slightly different from the RC delay model, and we will see how this is different. But this is also important because this is not only used for hand calculations, even in computer simulation tools. As the first iteration, the Elmore delay can be used to calculate the delay because it gives us a very good number, that is almost 90% close to the actual delay, but it takes only a much smaller amount of time. As we know, VLSI design, flow verification is very important part. So if I have some model that can give me the delay in a much quicker amount of time, that is very good for me. So Elmore delay is one such model. And finally, the linear delay model, again we will talk more about that as we go more into this unit. And the third point is very important because it tells us a way in which, so far, for example, RC delay model, Elmore delay model, linear delay model, you have a circuit, and using these delay models, you can get a number for the delay, say some 10 nanoseconds, 20 nanoseconds, whatever. But the next important question is 10 nanoseconds is too high. How are we going to reduce that delay? And like I said earlier, the design cannot be changed. We have to make it faster in some other way, and that is where the logical effort method of logical effort comes into the picture. And after that, we will see how to use that method to size the circuits also. And that's the last part of this unit. We'll also see some new types of logic families and what is the cost of gates in those families.